We're going to talk about machine learning and artificial intelligence today. And one of the things I encounter a lot when I talk to customers and potential customers is that everyone is taking the notion of using AI for granted. Right? It's a bit like you guys probably have had people ask you, are you doing blockchain in your startup? Or self-driving cars, right? There's some buzzwords, and AI has become one of these things that everyone talks about, but it's really poorly defined. And I kind of want to walk all the way back to the why and the questions we should ask ourselves about AI. So I'd really like sort of just to take a quick round on the panel to get things started to ask you, what questions do you see out there? What questions do you believe companies are asking that's leading them to choosing AI as an answer?
Okay, I mean, from my perspective, it's reasonably straightforward. If you look at where the app economy has gone, it's massive. If you look at what makes the difference between a service from Apple, a service from Google, a service from Facebook or Baidu, Alibaba or Tencent, right now it's still fairly early stages, so there's some differentiation to be had. But if you look at what happened to the smartphone industry, it commoditized very quickly, and what you're seeing is commoditization is creeping up into digital services. So how do you tell the difference between one digital service from one guy and the other digital service from another guy? It's going to be how useful it is, how deep, how rich, how intuitive that service is. And when that's all about software, it's going to be artificial intelligence that underpins that. So the reason why it's so interesting is simply because if your AI is better than the next guy's, your service will be better, and as a result, your opportunity to earn a return will be that much greater. And that's why I think it's so important.
I completely second that. Any business owner, any businessman will be looking to improve their business. And that with the prevalence and ubiquitous nature of data, statistical methods can now be used to provide visibility as to how these businesses actually work. If you're a manufacturer, you can use IoT data to automate your manufacturing process using statistical methods. If you're a retailer, you can gain insights into demand patterns. You see, you really struggle to find any industry where more clarity on how your business is run cannot be quantified, and using data simply provides more visibility and hence improvements for your business.
Mike?
Yeah, so basically I agree with that sentiment as well. I think that most business owners, they don't really care about AI at all and what it is. They see it more as a means to optimize their business. But I also think there's a second thing that they want to utilize, and that's basically that AI is hot today, and it's actually something you can throw into your pitch deck and say, we use AI, and that in itself is actually an argument for why your customers should choose you. So I think there's a competitive advantage just in name dropping it, and I think a lot of companies are getting into it just because they want to feel warranted to use the word AI.
Yeah, the alternative, very simple thing is to sort of make your service smart, but it just doesn't, engage the engineers, the investors, etc. Just as 10 years ago, everything should be easy to use. It's like, what's that? And so we had to invent all these kind of buzzwords like responsive design and things where just to subsequently get people to buy and people to sell, and so how you stimulate markets is by adding buzzwords, and AI is the new multimedia, which is the old cross-platform, and so.
Good. Well, it's certainly a buzzword that's touching a lot of people. Richard, you just published a report on AI. So you've been jumping the learning curve and getting your head around it, and you call the paper "Reality Bites: Practitioners and Pretenders," and that's sort of the inspiration for our session today. Why did you choose this topic, and in particular, why did you choose the title?
Well, I chose the topic simply because in the context of the whole digital ecosystem, AI is becoming one of the drivers of value, so it's important to understand it. The reason why we called it practitioners and pretenders is because these gentlemen have quite clearly pointed out is everybody is using it. And so you have to be able to differentiate who is actually really doing AI and who is actually pretending. And the reason why it's important to make that difference is because it's the real practitioners that will be able to generate long-term competitive differentiating advantage, which is where the money is, whereas the pretenders are the guys who are just effectively using statistics, and that does not provide them this differentiation, this long-term advantage, and so they will be commoditized out. So from a success point of view, from an investment point of view, you want to look at the practitioners rather than the pretenders, and what we did in the research report was to give you an idea of how to tell the difference.
And, you know, hype, of course, I certainly sense a component of hype in almost each of your answers. There is a lot of hype out there. Christian, Richard, you talk about this thing you call true AI. So that presumably relates to what the practitioners do, while the others don't.
Yeah, that's right. I mean, we have this nice little flow chart, and what we have 4 simple tests by which you can tell whether or not a company is a real AI company or a pretender. There are some very just to give you a nutshell, one of the biggest problems of AI today is it requires vast amounts of data to actually generate any meaningful conclusions at all. One way to be more effective on AI would be to reduce that. Another important thing on AI is the fact that when you create an algorithm, it can only do one thing. General purpose AI would be you've created an algorithm and it can then jump intuitively from one task to another. And a third thing would be to have the machines build the models themselves. Today, model building is a fairly intense, labor-intensive, and expensive process. And there are some odd issues around AI. For example, it's extremely difficult to teach robots to teach machines to do things that are very simple for humans, like walking or spatial awareness or these kind of things.
Drinking a glass of water.
Exactly those sorts of things. And these are the kind of things we look for when a company turns up and says, we do AI. That's the kind of thing we look for as a real, or someone at least has an understanding and trying to address that problem. That's a real AI company, in my opinion.
Nick, any comments to that?
I think it's important to distinguish between whether we're trying to create actual robots that can think and act like true human beings, or whether we are just using a fancy word for what is mostly just plain statistics. If we're doing the latter, then obviously it's going to take a while. And pretty much since the mid-1950s, people have continuously said that just give it about a decade, these new robots will be just around the corner.
True.
And guess what, guys? It's still about 10 years out. So don't hold your breath. However, having said that, there has been meaningful progress across a vast array of statistical techniques. You could call it machine learning or deep learning, you can call it what you want. It's all very complicated and super specialized, but you have seen very dramatic advances in a host of domains, and I hope we can get a chance to talk about how these advances have actually made meaningful differences across various parts of the economy.
I'm curious, Mike, if you can talk a little bit about how you went through the decision process where the answer ended up becoming, well, we have to do this using AI. What was the synthesis and the process that led you to that conclusion?
Yeah, well, basically it's because when you do an ad on TV, for example, you can do that and you can measure people's awareness. You can ask them, did you see the commercial? Did you like it? But then you also have to sell stuff, right? And right now when you have an airing, when you did the TV commercial, and then when your sales happened. But all of the sales that happen is not due to the TV commercial. So how do you figure out exactly how much was due to the TV commercial? There's a credit assignment problem in marketing. And we just wanted to help marketeers everywhere around the world in each vertical solve that by basically attaching and connecting the activity in media to hardcore outcomes. And to do that, we had to develop our own sort of machine learning methodology, if you will, to be able to quantify that and then deploy that into our platform.
And you're deployed today, and can you talk about some of your customer deployments and the benefits, the sort of hard benefits, and maybe some numbers on it? Yeah,
absolutely. So typically, when we compare our AI, speaking very broadly about AI, compared to a human media planner, we typically realize an uplift between 15 to sometimes even 50%, and that's not surprising because doing a media plan today contains maybe 5,000 different decisions. And 15 years ago, it was maybe 50 decisions you had to make. So the world is ever more complicated, and also most of the inventory is being traded on real-time exchanges. So it's very hard for humans to actually cope with that. So there are a lot of potential for uplift, and we have basically everything from automotive to consumer internet businesses, and that's really what we want to do: help advertisers get more bang for the buck, if you will.
I want to dig a little more into the perception versus reality, especially considering the hype today. How maybe what I'll do is I'll actually quote something from your paper here, which is the following. The apparent inability to teach machines to do even the simplest human task raised the question as to whether the approach being taken needs to change. Tasks that are hard for humans are easy for machines, and tasks that are easy for humans are almost impossible for machines. So you talk about robots being an issue, but if I think about some of the interfaces that probably touch most of people here, it's the voice interfaces we encounter on a daily basis, Alexa, Siri, and so on. And I don't know about you guys, but I find them not very useful. And in most cases, you get either a false positive or a false negative back. So how do I reconcile that so much money is going into this area, and yet the results are so disappointing? And I can tell you, I mean, from the point of view of Bang & Olufsen, we've been sort of wrecking our minds. Should we build voice into everything? And of course, as always, when the hype was at its max, we thought, we just have to do that. And then you realize when you start surveying customers who have actually bought Alexa devices, that their usage goes down dramatically in the months after they buy the product. I decked my house out with 12 Alexa devices and thought I'm really gonna dog food this and try and really get it under my skin, and I couldn't get my family or myself even to use it.
The problem you have, the way the voice assistants work today is they're taught a series of domains, which is basically a number of skills, which is it's kind of like it's a very narrow way of thinking about it. What really needs to change is that the voice assistants, they need to be able to understand context, circumstance, such that you can start to have a more interactive conversation with a voice assistant, and that's when you start to earn a significant return. And the problem with it is that's a really tricky problem to solve, and it's going to take a while. So you have
to say that it will take a while will probably be the understatement of the century.
Yes, I wouldn't disagree.
You could probably rightfully ask if it will ever happen. Every attempt to make rule-based solutions to questions like this have failed pretty much without exception.
And this is why you're seeing a proliferation of devices that have screens, because when you look at the information that can be conveyed by a screen, it's much greater than the information that can be conveyed by voice. So when you interact with a digital assistant, if the response comes to the screen, you get a better experience than if the assistant actually talks to you, and that's why you're seeing the screens materialize in all these devices.
No. So let's leave the hype behind and talk a little bit about the real applications out there. Maybe we just do a quick lightning round where we talk a bit about some of the impressive things where you've seen artificial intelligence actually being applied in a smart way that relates well to what is both possible today and what creates true customer value.
Okay. The top one for me actually in the last 12 months has actually been the Google Pixel 2, the camera. Now the phone itself, let me separate the camera from the phone. The phone was a total disaster because they totally screwed up the hardware. Let's put that to one side. The beauty part about this camera is, if you look at everybody else out there, everyone else has dual cameras. And what they do is they have this new thing in smartphone cameras, this thing called portrait mode, where the foreground's in focus and the background is nicely blurred. Now everyone else does that by looking at the difference between the two cameras, where they have a wide angle and a telephoto, and from that it's easy to calculate what's in the foreground and what's in the back. Google doesn't do that. The Pixel 2 has one camera, and they use AI to tell the difference. Why is that good? Well, firstly, because Google's portrait mode is just as good as anyone else's. And number two, it basically means they've made a substantial savings cost, resource cost, real estate saving, which means you can push that feature further down through the tiers at a lower price, and should help Google differentiate if only they could get the phone to work properly.
Beautiful.
I think one area that's maybe not as well covered as many other places is is using deep learning in genomics research, where actually you see the computational biology community now using neural networks to really model how cells work. And this is bound to have quite profound implications for our ability to treat genomic diseases such as cancer.
I think my latest favorite application of machine learning in AI was actually a startup who basically started off with one of the very famous data sets called CIGAR, which has over 100,000 different images of everyday objects. So what they allow people to do is actually that they can take their phone, and now imagine that you're blind, and they can just point their camera in a direction and then push a button. And then the phone will actually tell you which objects are in front of you and the distance to these objects. And you can actually also train it to recognize your family, your friends. So it will tell you, oh, Sophie is over there to the left. And if you go 30 meters, in a 10 degree, you will meet her and greet her. And that was actually an excellent application of how you can actually augment blind and deaf people to a very different degree than you could just a year ago.
So I don't actually have anything that has really blown my mind, but where I certainly do agree that there's fantastic scope is in the health space. So if you think about the sort of genetic composition of us, so we're all unique. So you have a sort of one figure on the one hand, it's like 7 billion, and then think about all the chemical permutations you can do from the food intake that we do on a sort of daily basis. So you multiply those two numbers with each other, then you get a very, very, very large number, and that has to be computed, in real time to fit what should you eat at any given time. Is this now good time to have a beer, or should you maybe have the wine instead? And we might get to those kind of solutions, step by step, and subsequently, make better food, make better life choices. And that's something that is the holy grail for me, at least.
Let me take that opportunity then to step a little bit into the future with you guys. A thing we often do at Cogniance when we go into a client is really to lift them out of present day and take them sort of 10 years into the future, because you kind of get out to the fog through the fog and out on the clear side, and you can really dream and think. So 10 years from now, we have Moore's law being 5, 6, 7 generations up, and storage is even cheaper, compute power is vast, it's on our wrists, and neural implants and everywhere. Where do you see this going in 10 years?
Actually, I actually think we might actually not be that different from where we are now. Simply because, it's already been pointed out that actually the progress that is being made in AI is glacially slow. There's the hype cycle, and then when you actually look at the amount of progress that's been made against these real kind of serious roadblocks to real progress, it's really, really slow.
So you're saying it's the practitioners, they will continue at it, but they'll make it incrementally better.
Let me give you an example. So the current technique that's currently used for all AI is this technique called backpropagation. That was invented in 1986, and it didn't start working until 2012. So if we want to do something, if there wants to be another technique or another big method, it might take a really, really long time to actually create it and get it to work properly. I'm sure you have a view on that one.
I'm tempted to point out that backpropagation worked fine in '86, but it was only with the Krzyzewski and Hinton paper that came out in 2012 where they actually managed to have neural networks that were large enough to actually massively drop the error rate on a standard image classification data set by 12 percentage points. Now, if you look out 12 years into the future, actually, can I just say that I disagree about development in AI and machine learning being slow? I actually think that data-driven transformation is really changing the world much, much more rapidly than most people appreciate. 10 years from now, I think the world will be a lot different. We will have self-driving cars, no doubt about that. The question is, what do we do with the Uber driver? Will we as a society be able to retrain him as a data scientist? If not, then we risk seeing bigger differences between rich and poor, creating all sorts of societal challenges.
Yeah, so I basically sort of agree with both and also disagree a little bit. A lot of things are going to change, but they're going to change in the product space. People actually getting to grips with how to use the existing machine learning technology and deploy that within their own platform. That's going to happen. So we're going to have self-driving cars, no doubt about it. Completely agree. But we are not going to have true AI because we lack the language of knowledge. We lack the language to describe to computer what context is. We don't have this today. We don't actually know how we remember stuff. We don't actually know how we represent people in our minds. That knowledge representation is not present today. And I don't think that will be present within the next 10 years either. So we as people have to do better. If we want to reach true AI one day, we have to do better. And we're far from good now.
I wouldn't be optimistic. 10 years from now, we'll have a gadget that we wear that will be able to delete the concept of, sudden cardiac arrest. Those types of solutions are already predicting, few minutes, predictions on medical data. I think with lots of weak, random, aggregated data, we will get very, very far in that field, combined with the advances of sensors, which is typically maybe 24 months for a cycle, so we'll do 5 cycles in 10 years. So, that's my dream, that we'll delete heart attacks, just like we're not lost anymore because of GPS in the phone.
So what this really echoes, certainly what you guys are saying, is that companies that do want to start utilizing artificial intelligence are not necessarily in a hurry. It's about jumping on the bandwagon and start iterating things and becoming, as Richard, as you call it, a true practitioner. Is that, would you generally agree that you're not going to jump into this and see very instant results? You may be able to apply it in your product, but the true breakthroughs are going to take a while before we really start seeing them.
If I may, the paradox is that the statistical methods are improving extremely rapidly, but adoption in industry is glacial. And that means that there is no time like the present for a business decision maker to actually start taking this seriously, which is probably also why you're seeing data science teams popping up in a multitude of very large organizations across Western Europe, certainly.
Let's talk a bit about the dark side of this. One of the things that I've been reflecting on lately is, I don't know if you heard about the incident where someone driving a Tesla killed himself. He was watching a DVD while driving, and the sensors in the vehicle did not see a semi-truck passing by because the angle of the sun and the color of the semi-truck simply caused the Tesla not to see that they just thought it was open road, and it slammed into this thing, and the guy killed himself. The outrage was quite significant in the U.S. over this, and one of the things I think, and I'd be interested to hear the panel's view, we are sort of accepting that humans will be responsible for humans dying, but we react very harshly when a machine is responsible for killing a human. And if you take self-driving cars, one of the things that people are very worried about is, how will the adoption stall when we start seeing traffic deaths, and what other dark scenarios do you see? And of course, Hollywood has already predicted a lot of them, but if we take away the most ridiculous scenarios, what some of the real challenging ones?
I'll say 2 things. Firstly, I think self-driving cars and autonomous vehicles don't really turn up until 2028. Largely because of the liability and the insurance issue. Is if autonomous cars can reduce accidents by 99%, that means the insurance industry is toast. And that people in the insurance industry will resist that for as long as they possibly can. Hence, that's why 2028 is my target. In terms of the whole, artificial superintelligence and machines becoming more intelligent than man, I would say if that ever happens, we're in deep trouble, because whatever safeguards have been put in place will not work. It's like a monkey trying to outwit a man, except that this time we're the monkeys. But also, a lot of these predictions are basically happening on 2040 are based on Moore's law. Now, if those who know the semiconductor industry know, is that we're getting towards the point in the laws of physics where the current method of making semiconductors is going to grind to a halt. So that means that the Moore's law is grinding to a halt until we come up with something else. Now, quantum computing, yes, but quantum computing requires you to produce a chip at minus 273 degrees centigrade. That's kind of a problem. So I think we may actually go through a pause, which is why my position on this is that Gordon Moore quite possibly has saved the human race.
Or you can write less code.
Indeed.
3,500 people are killed on a daily basis in traffic-related accidents. So it's a bit out of sync when people get hysterical, sorry for being blunt, about such an isolated incident. What has also happened recently is that people are no longer complaining about the airplanes flying by themselves. Actually, newsflash.
But that's because they don't know.
They've been flying by themselves for like 25, 30 years, right?
No, correct. So progress actually makes society better off, and people realize it.
I'm going to call you on this because when planes fall down, it's normal human error. It's not the machine that's behind the error, right?
So I'm from a small country called Denmark, where we are quite good at building large bridges. And we built some pretty big ones in that country. And there was a huge uproar a few decades ago about what are we doing, wasting billions of kroner doing these bridges, and what about the ferries and all that stuff. Well, guess what? We built the bridges, and the country is better connected, and people have, for some reason, magically stopped complaining.
So you're saying once we start seeing self-driving cars, for example, people will quickly realize life is better with them than without them?
10 years from now, we might just, have flying cars. Completely plausible. Who did not have an iPhone exactly 10 years ago? So all of you bought then an iPhone, first generation in this room, is that correct? But most people didn't. So in just 10 years, we've gone from almost no penetration of a computer in the pocket to complete penetration. So why couldn't we not, sort out, flying cars in 10 years? It might be much easier to navigate in three-dimensional space without elks than with.
We'll do a panel on flying cars next year. I promise.
And it's much more exciting than smarter ads on Facebook.
Mm-hmm.
Yes, but will it make money?
For some, yes.
All right. I'm just. We're getting close to the end and close to the Q&A session, but I wanted to just step a little bit into the machine room here, and I know that we don't want to go into a level of technical implementation here tonight. But if I was an enterprise or a consumer related company, how would you suggest that I get started thinking about this? Where's a good starting point for me to get my head around, and then, of course, other than calling Cogniance, but that goes without saying.
Well, the process, we've mapped it out. We've mapped it out actually in the research. Is that it's like a process that you go through, which is first thing you have to do is you have to be capturing the data that you're generating. You have to capture it so that it belongs on your server. One. Number two, you then have to work out, well, what is all this data? What is this data, and what does it mean? Once you've done that, once you've worked out what it means, then you have to go, okay, fine, now I know what the data is, what am I going to do with it? Mm-hmm. And that's kind of like a process. So if you're a complete zero at this point in time, I guess the best place to start is capture your data and work out what it means. And you'd be surprised by the number of people who can't even do that.
Yeah.
I would complement that with a design-led thinking workshop where you sit together with the business leaders and the specialists to actually try to understand where the business is coming from, understand their perspective in terms of how they run their business, and then people like Cogniance can use their skill sets to actually show the art of the possible, such that you then know what data to capture, at what level, with what frequency, etc., etc.
Like I've always done, thinking about the future, go back to the fundamentals, look at what kind of people we are, what type of daily problems do we have, try to understand, are these really problems, or are they just another nice thing to add, and then work out the use cases, see how they fit into our lives, and then see are there existing solutions that solve the problem, and if not, start working on them.
Great.
Can I just say that there might actually be low-hanging fruit in numerous verticals, retail in particular being one. No names will be dropped, but there are large players out there who are still worried about how putting down the price of Coca-Cola will affect their sale of Pepsi. Whereas there's really low-hanging fruit, not just in retail, but across other industries, where just starting out with the basics, disregarding rocket science, basic, simple steps can really improve the business. But it does require an open mindset on behalf of the business.
Great. I think this is a fantastic way to end the panel today. Thank you very much.